What I'd like to talk about is the search and selection in scientific databases, which is kind of hot topic in terms of meta-analysis because this belongs to one of the most common pitfalls in the flow of work. What is the aim of systematic search? And the word systematic is the key here, because the systematic means that you should capture all the relevant material from the literature. I mean all of them, not only those what you just favor. How can you acquire data? Data sources in meta-analysis mostly cover electronic databases. You can complement it with printed materials, printed journals as well, and it's recommended searching the reference list of the relevant, both the included and the excluded relevant articles, as well as the citing articles of the relevant findings, which may be searched for in the Google Scholar. The gray material, the gray literature, is a kind of new concept in meta-analysis. Gray means that it hasn't gone through peer review in this case. So when you got the questions in the beginning, which material belong to the gray ones, those articles published in the Hungarian journals but indexed in PubMed underwent peer review because, for example, Orvosi Hetilap is indexed in PubMed and there's a peer review process here. Some of you indicated that a PhD thesis published on the website of the university belonged to the white material as well, or maybe to the gray one. However, the PhD thesis did not undergo peer review process regularly. The conference abstract, well, these are specific issues because it depends on the congresses. Some of them have a kind of strict peer review process. However, in general, they represent a lower quality as compared to the published articles. So these are borderline materials. All the personal communications, emails, poster presentations belong to the gray one. You can use it in your meta-analysis. However, the reviewer cannot just review your data. If something is published, the reviewer can access to it. He can control it. However, your personal communication cannot be controlled. The data sources mostly cover electronic databases. Here I show you the mandatory ones, the Medline or PubMed, the Embase, and the Cochrane Trial. These are the three most common databases used in meta-analysis, and the Cochrane Handbook, the Bible of those making meta-analysis, recommends the mandatory use of these three databases. You can complement these with as many databases as you want. Here you can see some examples. However, neither Scholar nor Trip belong to electronic databases. These are search engines. They are not really recommended in use in meta-analysis. Only the function of finding the citing articles is relevant for us. There is one, the so-called BIOSIS, which is specific for gray material only. So here you may find some PhD thesis, some publications not indexed in the common medical databases, some non-English publications in the native language of the writers. These all belong to the gray material. If you have enough white data, do not use the gray material. If you use the gray material, well, the grade of evidence of your findings will be lower. Let's design a search. First of all, get familiar with the MESH system or the M3 system. They are database specific. MESH for Medline, M3 for Embase. These systems are hierarchical systems, and if you take a look at the figure, the concept is narrowing from above to down below. In this case, I just wanted to get all the information about ventilation and perfusion ratio. This concept may belong on one hand to the diagnostics of pulmonary embolism. So the upper figure, the upper hierarchy, shows the mesh tree of these aspects. However, this rate can be present in pathophysiology books because it's a basic concept of pathophysiology, which is an alternative approach, not the diagnostic one. The figure on the bottom shows this aspect of it. The end is the same. It means that one concept may be indexed to multiple hierarchical trees. How can you use it? If you want to design a search and you want to find all the synonyms, all the relevant terminology for your search, these mesh trees may inspire you to include some words. The mesh tree is for the automatic explosion of your search key because it's automatically used by the database. Okay, I'm going to show you examples later. The other approach is the application of free text terms. Free text terms, I mean you just type in your terms in the search bar of the interface of databases. You should include both synonyms, related words, variants in spelling, British versus American, and the truncation is a kind of interesting one. If you just put an asterisk just at the end of the trunk of the word, the database will just give all the variations. You can just finish. For example, antibiotic or antibiotics should be searched separately. By using this truncation method, you just spare time for giving all the variations manually. A query is typically the combination of the mesh terms and the free text terms. Here is an example from my first meta-analysis. This is not the best one I've ever seen, of course. You can see just the linking words and brackets as well. We'll talk about them later. The interesting is here that the query was automatically transcripted to a query transcript containing the mesh terms by the PubMed. That's the automatic explosion. Let's talk about these operators, the linking words, the Boolean operators. Set theory in mathematics. Boolean was the guy who invented them. If you put and between two words, it will narrow the search because the engine will just drop kind of articles which contain both of the words. For example, you want to recall all the articles containing both jelly and peanut butter. Only the cross-section of the sets will be called in this case. The other word, linking word, is the or, which expands the search. I like both peanut butter and jelly, so I want to have all the articles relating to these topics. In this case, I put an or in between, so I just get all the articles containing either peanut butter or jelly or both of them there. The not is not recommended to use in meta-analysis because by using it, you may lose interesting finding by accident. Just imagine, you're not interested in banana. However, in the abstract of the article, it is written that peanut butter, jelly, and banana are investigated in this article. By using the not Boolean operator, you just exclude this article from your search. However, both peanut butter and jelly, which are the relevant words in your context, are present. So I discourage you from using not in your search. Let's distinguish the operators from the search composed of quotation marks. If you use the operators, the database will give you all the findings containing these words in any order in the title, abstract, or search keys. However, if you just put your concept within quotation marks, it will only call those findings in the order given by you. Just compare the number of results yielded by PubMed. How to construct a search? Again, take the PICO, because PICO consists of concepts. The population, intervention, I think I lost. So the PICO contains concepts: the population, intervention, comparator, and outcomes. All of them should be described by your search, by the query applied in scientific databases. This is an example from the Cochrane Handbook. If you take a look at this, the P, children with substance abuse. This one was splitted into two concepts. One of the search defined the children, the pediatric population. The other one described the substance abuse, and the intervention and the comparator is incorporated into the third concept, because they only wanted those articles which are randomized controlled trials. I mean by that, any interventions compared in a randomized controlled way. If we take another example for this concept theory, let's take this one. If you take a look, the first row of the search key covers the P, the patients, the population of interest, because in this case, I was curious about those articles incorporating liver or spleen diseases, most specifically liver cirrhosis. The second row concerns the intervention and comparator from the PICO, because I wanted to compare the efficacy of FibroScan to other modalities, for example, LSPS, in predicting some of my outcomes, which is covered by the third concept, the presence of varices and varices needing treatment. The concepts are always connected with AND, because I need only those articles containing all the relevant concepts for me. Within the concepts, the synonyms and the related words are always given with OR. Again, expansion and narrow of your search. Mind the order of operations, the mathematical order of operations, because if you are not doing so, this will be the result. Let's modify the first search. I just eliminated one round bracket from the spot of the end of the arrow. I think the result is convincing. The last search yielded 5 times more results. However, if you think about the order of operations, I lost the concepts, all of my concepts, because in this case, celiac disease is the population, mucosal healing and recovery is the intervention, and villus atrophy is my comparator. If I just remove this one, this bracket, I just connected mucosal healing to my P concept. It is completely wrong. It will result in A-specific words related to the topic. I just lose time. After the design of your search key, the query, you can apply filters of the inbuilt filters of the databases. These could be features covering the genre or the design of the works. Let's talk about the designs. Actually, language is not a typical design, but theoretically it belongs to this topic. Mostly, we call only those articles which are written in English language because this is the convenient way. However, these searches are not really comprehensive. The Cochrane Handbook does not recommend incorporating any language filter. Humans. Meta-analysis mostly concern human subjects. It is really rare finding meta-analysis of animal experiments. You may find some systematic reviews rather in the topic. RCTs, or controlled trials, typical filters used by the Cochrane collaboration too, because these represent the highest level of evidence. And if you just analyze the highest level of evidence, if you aggregate it, the yield will be more valuable as compared to that scenario when you use low quality studies, of course. Time frames, for example, when you want to compare the era before a guideline and after that. These are the filters in the PubMed and Embase. You can find them in the left column. how many records should you get after you finish the search? It's a typical question I get. Actually, the answer is that I do not know, because there is no recommendation on it. It is possible that you only have a couple dozens of relevant articles. However, most of them fit your meta-analysis, and this is a comprehensive search. In other scenarios, you may have thousands of records, and only 2 or 3 of them fit your meta-analysis. So there is no rule for it. When you design the search, always think about your time and the precision, because your time is mostly limited. If I take my example, well, I may review 2 to 5 abstracts in a minute when I select the articles. In average, let's say 2. In an 8-hour shift, I can review about mainly 1,000 abstracts. What if I have 10,000 articles I should revise? That's a plenty of work. You have to balance the sensitivity and the precision of your search. Let's see the example. In this case, the search yielded only 10 records, and 2 of the possible 20 existing relevant articles were covered by it. This search is not good for us because we lost most of the relevant findings. Of course, we were really fast because we only had to revise only 10 records. At the other end of the scale, I just designed a search yielded 10,000 records. However, I identified 18 out of the 20 relevant articles. So my search is quite comprehensive. Theoretically, it's impossible to find all the records because most journals are not indexed in the popular scientific databases. Let's think about the small Chinese journals. Okay, so some records confirmed that half of the randomized controlled trials remain unpublished due to low quality, due to reporting bias, due to the low sample sizes. So the comprehensiveness is only a theoretical word. You should try to achieve as good coverage as it's possible. The optimal is somewhere here, because if you take a look at this part, you may see an exponential increase in the search yield and the time you have to afford when selecting, while the increment of the relevant finding is kind of linear. Okay, so this is the optimal range for the search. Some terminology. In the beginning of selection, we are talking about records, not about articles, because we have some conference abstracts, comments, and other genres in this case. Similar records, records from the same population, duplicate records of the studies should be linked together and handled as a whole one in the analysis. We should distinguish duplicates from overlaps later. Duplicate publications are... Can we fix it? So duplicate publications derive from the same population, from the same material. However, it was published in multiple journals, illegally, of course. Updates are status reports of ongoing trials, typically, while overlaps concern the overlaps between databases, because you know that most articles are indexed in several scientific databases, in average in 8 databases. If you take a look about the amount of duplicate references, they range between 1 to 10% maybe. This figure indicates the overlaps between the large scientific databases. You can see that the most important publications were uploaded to all the 4 large databases. However, there are some which are present only in one database. Another figure about the 3 most common databases, you can discover that most trials in the Cochrane database is incorporated in both Medline and Embase as well. What to do with the duplicates and the overlapping references? Think about it. If you download the content from 10 databases, you will have, well, 10 copies from some articles. It's quite time-consuming to go one by one through the same material. You can handle it by removing these overlaps, probably automatically by using some softwares for it. One potential software is the EndNote. That's what we use regularly, just because we have acquired quite a lot of experience with it. There are multiple other softwares for it, which can automatically check these overlaps and remove it from the pool, just to save time for you. The first what you have to do is to download the database contents, all of them, thousands of articles, thousands of records in this case, more specifically. Then this should be screened automatically by the software, by the Find Duplicates feature in it, which results in a near duplicate-free mass. It is not completely free of duplicates because, for example, typos, use of hyphens, use of punctuation may distort this automatic duplicate-free function of the software. So it's not perfect. That's why you should check it manually after it. In my experience, this automatic check just screens out around 95–97% of all the duplicates. So that's quite an effective process in general. Let's see an example of the search. When I applied the same query to 7 large databases, I got these numbers. If you take a look, the raw search resulted in 14,000 articles. When I applied the filters, in this case human and English language filters, this was shrank to 10,000 articles. However, after removing the overlaps, only 3,000 remained. I just spared my time by using this automatic duplicate eliminating function. Remember, the plan of the search takes days. However, the software and the manual removal of duplicates takes only a half an hour. After you just built up a duplicate-free pool in your reference manager software, the next step is the selection of these findings. The aim of the selection is to capture all the relevant articles from this pool. First of all, you need a selection strategy. This should be pre-planned. It is advised to have multiple persons to do the same selection process, just to check the agreement between the selection them, not to miss any relevant findings. Of course, you need a decision-making strategy, how to handle discrepancies between the review authors, and of course time, patience, and stamina, because it takes time. The aim of the selection is to preserve accuracy and reduce the bias of the selection. The end of the search will be an eligible article pool from which the data can be collected. The Cochrane Handbook recommends the application of a 3-step selection. First by title, then by abstract, and then by full text. And it gives a funnel-shaped figure of the selection, because most of the irrelevant articles are eliminated by the screening by title. Then you don't have to read all the abstracts of thousands of articles. Only a couple % of them goes through this selection process. And, which is the most important one, you don't have to download 1,000 articles from PubMed or from other sources to revise all of them, only those which were just passed through this title and abstract selection process. Again, save your time. This is the interface of EndNote, the reference manager software. You can see on the top a folder with all references in it. All the articles, imported and downloaded to the software, and the most important features downloaded from the databases, including the title and the abstract. So you don't have to work on the interface of the electronic databases. All you need is a reference manager software. You can create multiple folders. Tomorrow we are going to practice it to select. Before you start selecting, let's have a plan. Define your eligibility criteria. Otherwise, all those participants of selection will apply different criteria, and the end of the selection will differ. The agreement between those selecting will be poor. We recommend using inclusion criteria based on the content, and these are defined by PICO. In this case, the P is covered by these two: celiac patients adhering to gluten-free diet. The intervention and the comparator are incorporated as well. And of course, the outcomes here are not really pre-specified, because I didn't know what to expect at the very end. Selection criteria should include the design of the studies. Case studies, case reports, conference abstracts, letters, comments, editorials should not be included in the work. Only original studies should be included in meta-analysis and systematic reviews. The most favored study designs are randomized controlled trials because they represent the highest level of evidence, as I mentioned before. The other branch concerns observational studies, and they suffer from potential sources of bias. The two common study types we are working with are the cohort studies and the case control studies. Cohort studies are prospective studies, and prospective means here that the outcome happens later than I start my project, while case control studies are rather retrospective studies. Of course, in general, in this case, the outcome has already happened when I start collecting the data and when I design my project. So if I review the medical system to collect data from a disease and from a control group, that will be a case control study. If I follow patients for several years and measure survival, for example, that will be a cohort study. These are the two most common observational study types in meta-analysis. Always make the selection process as transparent and as reproducible as possible, because the reviewer should be able to reproduce the whole searching process based on the data you provided. Provide both the query, the name of the databases, the exact keywords, all the filters, the date of search, draw a flow chart, and of course, provide reasons for why you have excluded some articles. Again, it is advised to do the whole selection process in duplicate, so we need at least 2 review authors, and the agreement can be measured mathematically by the Cohen kappa. It's a quality indicator of selection. Provide details how the discrepancies were resolved between the review authors. And at the very end, you will have all the eligible articles ready for data collection. The take-home message is: plan before you act. It is really important that you prepare a detailed plan of the search and selection strategies. And if possible, record it in the protocol of your work. Otherwise, you will get the comment from the reviewer, as you may see here for my first article: the search is poorly designed. Why? because I just let the mesh terms, the automatic explosion, to include synonyms or synonym-like words, because the database cannot distinguish that the mucosal recovery here means the intestinal mucosal recovery, not the skin. So that's a methodological error. Thank you for your attention.